quickly review, so this is continuation of programming lecture. Let's quickly review functions. So here is the function, a general outline of a function. First important thing, if you're creating a function that you want to call with different variables, is that you have to tell MATLAB, this is so-called reserved word function, that signals, okay, function coming, and then the syntax after that is interpreted as follows. Name of the function is important. It's important to have that name the same as the name of the file. Okay? So when MATLAB, when you type in name of the function, and we used so far a lot of functions already that are pre-programmed, for instance, size. Okay? Then MATLAB actually goes and searches for a file called size.m, which exists somewhere in some of the folders that MATLAB knows about. So MATLAB has a bunch of folders with its commands, and basically it goes and searches for the folder called size. So that's why it's very important to name the function the same as the file. And then after that we have regular brackets and the list of input parameters separated by comma. And if you want to pass anything outside of the function, normally whatever is in the function stays in the function, no pun intended. Okay? So any variables or anything that you define would actually stay inside without being passed outside. That information that you actually want to give to the outside, you put in the list of output parameters, and we would put those in square brackets. If you have only one output parameter, you can omit those square brackets, but it's a good idea to always put them there. Okay? So this is a function that takes x and y, it does something with them, it computes f and g, and passes them out. It is always a good idea to put a comment on what is function doing. So actually, that way you can ask for help. So let me actually quickly type. You should have this function if you work through the... So I'm going to quickly type it up. And you put end at the end of the function, though if you skip putting it, it's still going to recover if you only have one function in the file. So I'm going to say if is, I'm just going to define a different function. G is, doesn't really matter what I'm computing here, it's just an example. So again, what I always put as part of this help comment is the syntax of the function, and then you say compute f is x, and so however quickly you do it, it's better than nothing, though at later iterations when you're working and creating your functions, you might want to clean this up and make it real nice. So for instance, you could say input x, y are real numbers, output f and g. Okay? Save under the same name. So now one thing that is nice about typing in this comment is that MATLAB is programmed that if I say help to function, okay, it's going to go to the file under same name and look whether right after defining function there are any comments. And if there are, it's going to print them. Okay? So when I say help, it's going to print precisely what I typed in there. That's precisely when I say help size, which is the built-in function for MATLAB. It's going to print, it has the preamble with these comments of how size functions, and that's what it's printing when you type help for anything else. including hyperlinks here to further comments. So it's really advanced that way. So you want to actually, if you are building a larger code, having that help at the beginning really helps, no pun intended, because you will forget what you intended to do. Now let's play with this a little more. Let's say that I actually defined, you can just overwrite in your function whatever it is. So I'm going to just define a temporary variable that is equal to 4 inside this function. Now you can actually, if you uncomment the semicolon, MATLAB will print out as it goes. So let's see how it executes. So let's say that I say to func of 4, 5. Okay. So it should execute assign 4 to temporary variable and compute f and g. And basically you will see things printed out. Temporary is 4, f is 9, g is -1. Do I have f and g now in my workspace? No. Do I have temp in my workspace? No. So that's this part of whatever is in function stays in function until I grab it or pass it to the outside. So I should actually, and I can define something under different name. f1g2 is to func of 4, 5. And then yes, f1 will become f that I wanted to define, and g2 will become -1. Okay. Will I still have temp? TMP? No. Stays in function, because it was never passed as an output parameter out. So here, in this function, f and g are output parameters, but TMP is not. And typically you will leave things uncommented until you verify that you've done everything correctly, and then you put those semicolons back so that the execution of function is clean without much. Okay? So again, only those variables that I'm ready to pass to the outside are actually output variables. Okay. So let's get moving to add more stuff to my function. So now, one thing that you could have multiple functions allowed in the file. The first one that you would have, then you have to put an end function in, and I would suggest that you always do so. And that's the primary function. And any supporting function in that file, there could be multiple others, is a secondary function. And those cannot be viewed from the outside or executed from outside of that file. So if you had some supporting functions, you can define as many as you want. Okay? If you have any supporting functions, you can add them at the end of the file, but they're not going to be visible to the outside unless you gave them their own file. Okay? So if you want function to be executed or found, it should have its own file. So let's actually create a function now. Here is an example. So let's calculate area and perimeter of a regular n polygon. So here are some examples for n is 3, 4, 5, 6, 7, and 8. Okay. With their own names. And we actually have formulas from geometry for those. You can define the side S, which is 2 times r times tangent of pi over n, where n is number of sides. Area is n r squared sine of pi over n. And perimeter is 2nr times tangent of pi over n. So how about you create a function that takes n and r and computes S, A, and P. you can do it either way. You could also make anything else input, but let's make it simple. So let's create a function, give it a name, some meaningful name. Monday is cute, but you're not going to remember that you worked on this on Monday. So this function should have some name that reflects of what it's doing. Area perimeter, polygon function, you name it. You name it, but it should make sense. And I want R and N to be input. And if you feel that you want to be challenged, then you can put S and N as input. But either way, I want to compute area and perimeter. And I think that's slightly different from what I said first time around, so I'm going to write it down here. So output is area and perimeter. Input, you can have a choice. Either your N and R are input functions, or N and S. This is a little, one more line of writing. Is it good? Getting there? Test your function. So testing means actually computing something by hand for some n. For instance, for n is equal to 3, and make sure that it's doing with some numbers, test numbers. Three outputs. Sure. As many outputs as you want. You can have outputs S, A, and P if you like. Most of the time, you're the designer. There's something that is assigned, but there's always a little bit of flexibility. And call it something else. Second thing that you want to test is like, okay, what will happen? Does my function make sense if I put n is equal to 1 or n is equal to minus 2? What is it going to do? So I'm going to quickly write it. I think I mixed them up. Tangent. Oh, okay, actually. So something like this would be the simplest ways. Uh-huh. Pi. Oh, no, not in both. In all. Oh, no, there's no pi. Okay. N. Never mind. I need my coffee. All right. I was working from memory. My memory doesn't work well without coffee. All right. So this is the simplest way. And now if I wanted to execute, I would say AP, this way I want to remember the output, area perimeter of, let's say that I want to do 3 and 1. Okay, so triangle in radius 1, I'm going to get my results A and P. Now if I actually wanted to execute with minus 3, it's still going to actually compute, but it's not going to tell me that something's wrong. And in this case, it actually recovers, even though that mathematically we cannot have minus 3 sides. It's going to have a negative value here, and actually negative value for sine and tangent that is going to recover and be just fine and give me an output that is for actually n is equal to 3. If you want to do something for 0, it's gonna spit out zeros or not a number. Okay. So the point I'm making here is that even computers sometimes look very smart. They're as smart as we program them. And technically, one should program this function to say, no, you cannot use this function for n is equal to 0, because you're going to get not a number. And if you had a larger workflow that executed this function, and somehow wrongly for not a number, that would introduce errors in your computation, and at the tail end of it, you could blow up a valve, okay, if you didn't have correct numbers in there. So it's very good to actually put some checks in there. And we're going to get to some control structures that will allow us to actually check for things. But for now, let's just everybody make sure that you put in comment in there. Or what is the function doing? So I can put input n number of sides and r radius, output area of n polygon area and perimeter. So this is a very quick comment. I could do this a little more nicer, but it's better than nothing. And most importantly, if I now type in help, I forgot how to use area perimeter, I can actually check on it without opening the file. So when I type in help, this will be printed. So that is kind of really neat. So please upload this function to Canvas. You can work on it a little more if you want to, or just upload what you have. It's more like a check that you've been working on things. Here's another way to do this. So this is just a much nicer, cleaned up preamble here about what function is doing. This one I decided to call polygeom, Sn, and it's actually taking S, which is the side, as an input. So this is another variation of the function, in which case we have to compute the radius first and then use it in area. Now in this case, I have decided to go one step further and use subfunction to compute area and subfunction to compute perimeter. This is just for readability. The first way you wrote your function is correct, but it's harder to recognize, especially on Monday morning when you're looking at this line. It's hard to recognize, oh yeah, that's an area of n polygon. I mean, if I quiz you next Monday, you'll be struggling remembering the formula, right? Not to mention a year after. So it's actually good, we're writing, if you want to write code that can be read by you and understood by you a year later, and overall some other human that has to actually go through your code, then it's actually good. So the moment, if I call this function area, I immediately know, oh yeah, this is computing the area, and oh, this part is computing the perimeter. Okay. So it's just, this is a matter of design. Both ways that you coded first to begin with, and this are correct. It's just that this one is much more cleaned up and readable. And most often as you're designing the code, first you're going to do it quick and dirty. As long as it works, it's fine. And then you're going to improve it as you go on. So think about coding, or any work for that matter, as iterative process that gets improved. Just like writing, for instance, right? Your first draft is never the one you submit. You always kind of work on it a little later. Same thing with coding. So this would be a very nice, cleaned up way to document what your function is doing and also make it a little more readable for humans, including yourself. Yes?
What would you put in after writing all the subfunctions in this case?
Do you put what?
In? Like,
And yes, so in this case it's not, but it's in MATLAB will figure it out,
okay.
but correct syntax would actually, yes, have ends in every function. And depending on the, so MATLAB is a little easier to use, as in it's programmed to recover even when you make mistakes. Not all programming environments are like that, and some of them are really picky. Fortran and Python, for instance, you have to have exactly certain number of spaces here left before you start. Like code has to be lined up, and sometimes you don't, or you miss the space, and you're like, what is wrong? and it doesn't want to execute. So again, different environments are more pickier than the others. Part of using the MATLAB as a starting one is that it kind of allows for a lot of mistakes to be made and still recovers. Okay, so let's now actually go get more interactive. What if you actually wanted to ask the user to give you n and then work with that? Okay? So for instance, you could actually, there's so-called input function, where you ask the user for input value, and then you take that value from the user typing it in, and move on. Okay? So let's actually quickly do that here. I'm actually going to remove from my area perimeter. I'm going to remove n as an input variable. And I'm going to ask user to provide it. So I'm going to just say a input, and then I'm going to put some text as guideline. Input, give me number of sides. So again, this part of the text is just a guideline. What is it that you're expecting to be put in? So let's execute this right now. So now I don't need n. So now function will ask me for input and pause. When I put 6, I need to press enter. It's going to continue and compute what I wanted. This is how a lot of programs that you're using are functioning, right? They're asking you for some input. You could do multiple ways with it. So your input could be a string. You might want to display. So string is simply a character string. So it's really an array of characters. And already we have used this. The moment I put single quotation mark, okay, that signals that this is it's supposed to be interpreted as text, not numbers. Okay. So this text is simply then printed. So this is a string. Let's call string 1 is, I'm going to copy that string. So you can actually see now that this string 1 is just a text and simply a variable that can store text. Okay. You can then do fun stuff with it. Let's say my name, this is just a little more on strings. My name is Masha. And my last name is, can you spell my last name? I can make that a quiz one of these days, just for kicks, just to see what am I gonna get at. And then I can actually kind of put them together. I can just say name, last name. Okay, it's gonna just put them together. Oops, maybe I need a space in there. So I can just add space, like this is a string as well. Just because it's empty or you don't see it printed, it doesn't mean that it's not a character. It is a character. Because it has to leave, the computer has to leave space for it, right? So I can concatenate strings and manipulate them. I could ask what is the size of this. Oops. it's a row of 15 characters, by the way. So each character, by the way, each character that is interpreted as text is actually a number, and that number is between 0 and 255. And then the computer has a map that interprets those numbers and prints out a character instead of the number. Okay? And there are codes for that. And sometimes when you get from a different part of the world, you get an email from somebody and it appears that their name is jumbled. That happens for special characters in my name a lot. Okay? That means that they sent you something from the keyboard or the part of the world where there was one set of codes to interpret that text, and they sent it to the area of the world when that code is different, so things got misinterpreted, and that's how you get junk printed. And then also sometimes it's difficult to catch if there are similarities in these codes. Like for instance, between Croatia and the US, there are similarities because alphabet is still Latin. But then if it's coming from China or Korea or something that there's like a whole different set of characters, then that can get. So that's just a quick. All right, so these are strings. So I can display strings. I can just say display name, and it's just going to display it. And there's a number of other functions, but these are just the basic things, how to manipulate strings. Now, one thing that you could do, and give this a try here without me typing it in necessarily, is let's quickly differentiate numbers and strings when their numbers are part of strings. So for instance, if I assign 4 to a variable x, it's interpreted as a number. Okay. I could convert it to string for printing by saying number to string, NUM2STR, okay. And then I can display that. So give this a try. So basically, number in itself is not a string. If I want to display it using display function, I have to interpret it as string. And this will do that. So this out string that is going to print it, it's going to put x is equal to as a string. And then it's going to convert this x to a string and concatenate the two. So give this a shot. And basically this should be the display that you see. This should be the display. So x right now, x is equal to 4. X is a number, and we can do 4 plus 6 and compute with it, right? Now, if I wanted to use display function to simply print it, it should interpret it as string, not a number. So for it to do that, and just print x is equal to 4, now there's different ways to do it, but if I want to use display function wants a string. And right now, x is not a string, so if I want to convert it to a string, and just treat it as text. But then once I treat it with text, I cannot do this. I cannot do standard operations now with it. Certainly not correctly. So actually I can show you that. So if I had x is equal to 4, so x is 4. Now if I want to do x plus 5, that's 9, right? Now if I do num to string of 4, you can see that it added these. So now it's treating it as text. If I add it plus 5, I'm going to get 57. So what does that mean? That means that actually 4 as a text is interpreted as as 52, as a number 52 in its internal. Okay. So it's ultimately treating this string as a number, or manipulating with it as a number. But every time human asks, oh, display 4, this is now just displaying 4 for me as a. Internally, it's actually 52. so yeah, this could get you in calculation trouble, all kinds of calculation trouble and errors. A question? There was a question?
I just have trouble getting it to work. Can I put it in not the square portion with x equals and put it right next to it?
And T. The 2 is the other. So just the name of the function is NUM2ST. This. So why is this important? Because computers typically have to take input from humans and also display output in some meaningful way. So if I go and compute something complicated, I should be able to communicate that properly to somebody. So that's why it's important to print or display the output. Here's a more formal formatting of the printout. So fprintf is a command that is a little cryptic, but it can manipulate all kinds of variables together. But I have to tell it every time what it is that I'm trying to print as text. So for instance, if I wanted to say Elvis, here's the name, is 17, okay, then fprintf would say, okay, first I have to tell it I want to print a string, okay, which is text, which is this name. So this S is telling me it's a string. And then I want to say, treat this as an integer number. And why does D stand for integer? I don't know. Years old. And then there's this character here saying jump to a new line, so that this is nicely formatting. So let's try to do this. And do it for yourself, don't do it for Elvis. So I already have my name as a string. You can put yours. So my age is 40, thank you for asking. So basically fprintf, I could say so this is where I want to put Masha is 40 years old. So I already defined the variable name. But if you didn't, you can just put your name like this. So basically what you could do here in front is name is and you can write multiple commands by the in the command line. You just have to separate them by semicolon. So this is how it would write it down if I didn't add that special character for jumping to new lines. So if I add it right here, then it's going to get to the new line before it prints these characters for command line. And for that matter, I can do it at the beginning as well. So I added new line here, so now I have an empty space here, but it's easier to read. So it's optional, but it's easier to read. So this means jump to the new line. And then this is a string. And whatever is here, interpret as a string. And then whatever is the second one, interpret as integer. And again, why is D an integer? I don't know. So string, integer, new line. Now my age could be 40 and a half, though we rarely treated age with that much resolution, if you will. In which case it would have a little bit trouble displaying this because I told it it's an integer, but I gave it something else, and this is how you get garbage. I mean, this is actually interpreted correctly, it recovered. But I might wanna, so floating point number, this actually, it recovered. It just gave me scientific notation. But F is correct for floating point number. Or G, in G is going to do a little bit of cleanup. It's not gonna put any extra zeros. So F and G. And yes, if I wanted to scientific notation, I would put E, which is what it basically figured out. Yes?
So what does G stand for?
G will just, it's floating point number, but it's going to clean it up so it's nicer output without extra number of, like, extra zeros in this particular case. Now, I can modify, and F I can modify. G I cannot modify, but I can actually say, oh, give me 7 or 10. So 2 is just like kind of leave the space for 2 at the beginning, and 10 digits. This 2 is often ignored at the beginning, and then it's going to put 10 of them. Okay. So you can tailor this really precisely to some sort of lined up table that you would like. So again, this leaves 10 digits, should you want it to. Now, for my age, obviously, that's an overkill. But I wanted to. So if I just say pi is equal to what it's going to do by default, it's going to give me 6. But I could have put, give me 14. And for number pi, that's important. Right? So I can design how many significant digits I want. Yes?
What's the point of the 2 again? You said it didn't show up.
2, it doesn't, it's supposed to actually leave 2 spots for this 3, but it doesn't. It's still 1. It actively ignores that. You have to put something. It might actually might work without. Yeah, it does. It just kind of ignores that spot. And again, I can be really 140. Yay. Now, we know that pi can have digits as many as I want, right? My computer knows about this many. And then after that, it's zeros. And we're going to get to that. There's a finite storage for numbers, and they're not exact. I cannot have infinite number of digits the way pi does. Okay. So I can discover that when I ask it to print 140. The rest are zeros, so it's filled in. So there's an error involved when we are storing real numbers in computers. We're going to have a whole lecture on it. Yay. Okay. So now I know how to get my input and output better. Fprintf by default if I just use it as format and variable, it's just going to print to screen. But I can actually define open a file for writing and tell it to write to that file precisely in the format I like. Whatever text I want to put here or numbers or whatever it is, it's gonna, here's like formatting, right? So I can modify this, I can format this output some nice way to give it to my colleagues if I wanted to. And this is going to be a text file that is easy to open and read everywhere. So again, I can open the file for writing, and then I can give some hint what is in this file. So in this case, k is 1, x of k is 6, and then just print k and x of k and close the file. Okay. So again, just as a recap, we have scripts and functions. So what is the difference between today I reviewed mostly and we worked with functions. What is a script as opposed to a function? What is missing in a script? First word function. Do I have input variables? No. Do I have output variables? No. It's just going to execute all of the commands that I put in the script. It's going to execute them in my workspace. And I have to have, if it needs something for computing it, I have to have it in workspace, or otherwise it's going to yell at me. Okay? So I cannot give it some input and modify that. So if you remember, there was one script that we basically just saving a bunch of commands. If you remember that plot temperature. Okay? So this is basically a script. I'm just telling you what to do. Let's see if it still runs. And I can just run it. There we go. So it runs because I still have that that function. Why did it separate now? I love when I do a mouse movement that does something that I didn't want it to do. So basically it will open that file. Now if I didn't have that file, okay, if I asked it to, I have a typo here, and if I execute, I think it's still gonna run. The problem is that I didn't save it. So it tells me invalid file identifier, so it actually couldn't find the file. Okay. So I have to make sure that I have things correct. All right. That is it for today. So basically we know about basic scripts and functions. We know how to make our input and output pretty. We know how to get input variables from users and then display them, the results nicely. And we're going to add some control to our flow of commands starting next time.